Welcome to AQA Combined Physics. Atomic structure. 20 questions. Read each question, choose your answer before the timer runs out. Let's go. Question 1. The nucleus of an atom contains. Option A, protons and neutrons. Option B, electrons only. Option C, protons and electrons. Option D, neutrons and electrons. What is your answer? The answer is A, protons and neutrons. The nucleus is tiny and dense, containing positively charged protons and neutral neutrons. Question 2. Atoms have no overall charge because. Option A, the number of protons equals the number of electrons. Option B, they have no charged particles. Option C, neutrons cancel all charges. Option D, they are too small to be charged. What is your answer? The answer is A. The number of protons equals the number of electrons. Equal numbers of positive protons and negative electrons mean the charge is balanced to zero. Question 3. The radius of an atom is approximately. Option A, 1 times 10 to the minus 10 meters. Option B, 1 times 10 to the minus 5 meters. Option C, 1 times 10 to the minus 15 meters. Option D, 1 meter. What is your answer? The answer is A, 1 times 10 to the minus 10 meters. Atoms are about 1/10,000,000th of a meter across. The nucleus is 10,000 times smaller still. Question 4. Alpha radiation consists of. Option A, high-speed electrons. Option B, electromagnetic waves. Option C, 2 protons and 2 neutrons, a helium nucleus. Option D, neutrons only. What is your answer? The answer is C. 2 protons and 2 neutrons, a helium nucleus. Alpha particles are heavy, positively charged helium nuclei. They are stopped by paper or skin. Question 5. Beta radiation consists of. Option A, high-speed electrons emitted from the nucleus. Option B, helium nuclei. Option C, electromagnetic waves. Option D, protons. What is your answer? The answer is A, high-speed electrons emitted from the nucleus. A neutron in the nucleus turns into a proton and emits a high-speed electron, beta particle. Question 6. Gamma radiation is. Option A, a particle with mass. Option B, a helium nucleus. Option C, an electromagnetic wave with no mass or charge. Option D, a slow-moving neutron. What is your answer? The answer is C. An electromagnetic wave with no mass or charge. Gamma rays are the most penetrating radiation. They are not stopped by paper or aluminium. Question 7. Which type of radiation is stopped by a sheet of paper? Option A, alpha. Option B, beta. Option C, gamma. Option D, all three. What is your answer? The answer is A, alpha. Alpha particles are large and heavy. They are stopped by paper, skin, or a few cm of air. Question 8. Which type of radiation is stopped by a few mm of aluminium? Option A, alpha. Option B, none of them. Option C, gamma. Option D, beta. What is your answer? The answer is D, beta. Beta particles are smaller than alpha and penetrate further, but aluminium stops them. Question 9. Gamma radiation is reduced by Option A, paper. Option B, aluminium. Option C, thick lead or concrete. Option D, nothing can stop it. What is your answer? The answer is C, thick lead or concrete. Gamma has no mass or charge, so it penetrates deeply. Thick lead or several meters of concrete are needed. Question 10. The half-life of a radioactive isotope is Option A, the time for all atoms to decay. Option B, the time for one atom to decay. Option C, half the lifetime of the sample. Option D, the time for the activity to halve. What is your answer? The answer is D. The time for the activity to halve. Half-life is the time taken for the number of undecayed nuclei, or activity, to halve. Question 11. Radioactive decay is Option A, predictable for individual atoms. Option B, controlled by scientists. Option C, caused by heat. Option D, random and cannot be predicted for individual atoms. What is your answer? The answer is D, random and cannot be predicted for individual atoms. We cannot predict when a specific atom will decay, but we can predict the behavior of large numbers. Question 12. When an atom emits an alpha particle, its mass number. Option A, increases by 4. Option B, doubles. Option C, stays the same. Option D, decreases by 4. What is your answer? The answer is D, decreases by 4. An alpha particle carries away 2 protons and 2 neutrons, reducing the mass number by 4. Question 13. When an atom emits a beta particle, its atomic number. Option A, decreases by 1. Option B, stays the same. Option C, increases by 1. Option D, increases by 2. What is your answer? The answer is C, increases by 1. A neutron becomes a proton, atomic number up by 1, and emits an electron, the beta particle. Question 14. Nuclear fission is the process of Option A, joining small nuclei together. Option B, absorbing neutrons without splitting. Option C, emitting gamma rays only. Option D, splitting a large nucleus into 2 smaller nuclei. What is your answer? The answer is D, splitting a large nucleus into 2 smaller nuclei. Fission of uranium-235 or plutonium-239 releases energy and neutrons, which can cause a chain reaction. Question 15. Nuclear fusion is the process of Option A, splitting large atoms. Option B, joining two small nuclei to form a larger one. Option C, chemical combustion. Option D, radioactive decay. What is your answer? The answer is B, joining two small nuclei to form a larger one. Fusion powers the Sun. Hydrogen nuclei fuse to form helium, releasing enormous amounts of energy. Question 16. A nuclear chain reaction occurs when Option A, fusion stops. Option B, each fission event releases neutrons that cause further fissions. Option C, the reactor cools down. Option D, alpha particles are absorbed. What is your answer? The answer is B. Each fission event releases neutrons that cause further fissions. Neutrons from one fission hit other nuclei, causing more fissions and more neutrons in a self-sustaining chain. Question 17. Which scientist's experiment led to the discovery of the nucleus? Option A, Thomson. Option B, Bohr. Option C, Rutherford. Option D, Dalton. What is your answer? The answer is C, Rutherford. Rutherford's alpha particle scattering, gold foil, experiment proved the atom has a small, dense, positive nucleus. Question 18. Contamination by radioactive material means. Option A, being exposed to radiation from a distance. Option B, unwanted radioactive material getting on or inside a person or object. Option C, standing near a gamma source briefly. Option D, using a Geiger counter. What is your answer? The answer is B, unwanted radioactive material getting on or inside a person or object. Contamination is when the material itself is on you. Irradiation is being exposed to radiation from a source. Question 19. Background radiation comes from. Option A, only nuclear power stations. Option B, natural sources like rocks, cosmic rays, and radon gas, plus some man-made sources. Option C, only the sun. Option D, only medical equipment. What is your answer? The answer is B, natural sources like rocks, cosmic rays, and radon gas, plus some man-made sources. Most background radiation is natural. Radon gas from rocks is the biggest UK source. Question 20. In a nuclear power station, energy from fission is used to. Option A, directly power homes. Option B, heat water to produce steam that drives turbines and generators. Option C, create fusion reactions. Option D, produce alpha particles for medicine. What is your answer? The answer is B, heat water to produce steam that drives turbines and generators. Fission heats water, steam turns turbines, turbines spin generators, generators produce electricity. How did you do? Comment your score below. Subscribe to Advisory Science for more GCSE revision quizzes.